So here's what we created last time, right? The basic monoalphabetic substitution cipher using custom arrangements of letters. We talked about having a keyword like tacos, but how do we allow the user to define their own keyword, which would make this a much better program because then different people could use it, and if someone got your program, they wouldn't necessarily be able to crack your code immediately because they don't necessarily know your keyword, right? So how do we do that? Basically, we're going to use something very similar to what I did here with this. So this is looking for the letters of their secret message inside of valid letters. What we could also do is we could do this in a similar way. We could tell it to look for the letters in their key, so user key, inside of valid letters or inside of something else, and tell it to then construct this key, first using what they inputted and then just filling in all the other letters afterwards. So I hope that made sense, but that's what we're going to do. So we're going to just modify our pre-existing program. Let's put in input and enter your key. I guess we can close this down here from the previous session. And let's make it dot lower. And so this is going to equal an empty string for right now. So now what I'm going to do is I'm going to make it basically a duplicate of this. So for char in user key, if char in valid letters, then key plus equals char. So what this is going to do is, just like the one above it, it's going to add in the user's key into the key we're going to actually use in our encryption method. However, we still need to add in the rest of the letters. So how would we do that? Let's go ahead and write another one actually. We're going to do now for char in valid letters, if char not in, I think we can do this, not in key plus equals char. So now what this is going to do, assuming I got this right, this is going to say that once it's done the user key, once it's put in whatever, so zombies or whatever, it's then going to run through this string here, and it's going to look for each and every letter. And if that letter is not already in the key, then it's going to add it into the key, which should construct the rest of that key that we had before. So like before we had tacos, right, with the rest of the alphabet afterwards, right, etc. Pretend the rest is there. It's going to basically do that same thing. They're going to put in their key, like tacos, and then it's going to search for this, and any letters not already in here, it's going to add in and build in the rest. That should be what happens. Now, there could be some complications, and I know we're going to run into at least one because I intentionally haven't shown everything yet. So let's see what happens. Yeah, I think we're far enough along to see. Ooh, basic monoalphabetic keyword cipher, which is still a substitution, but it's fine. Run substitution, enter secret message. Tacos are awesome. Enter key, tacos. There we go. I think it worked. Let's have it print the key too, just so we can make sure that it actually worked. So down here, I want it to print the key as well, just to make sure that it looks like all the letters ended up inside of the key. Run. Tacos are awesome. Tacos. Look at that. Tacos, B, C, oop, the C's gone because it's in here. B, D, E, F, G, looks like it's all there, and the space is there too, so that worked. Now, there is a problem with this. What if the keyword has a duplicate letter in it? So, like, tacos are awesome. Maybe the key is tortilla, right? So it's got two T's and two L's. What happens? So it looks like it worked, but a problem is there are 2 T's and 2 L's in here, and so this string is actually longer than the 26 plus the space, and that's a problem. And why is that a problem? So let's see. So if we think about the message tacos are awesome, and we look at our thing here, do we have any... Okay, so here we have this T and that T, and actually even the space is kind of an issue. The space is gone. The space is way back here, and so we have no spaces in here. So here's the A in tacos, here's the A in awesome. That's fine. What letter is that? Taco, let's see, T-A-C-O-S space A-R-E space A... Oh, okay. A in tacos, A in R, A in awesome. That part's fine. What about the letter L? Is that a problem? Oh, we got lucky actually. But what if we didn't? Let's try a different message. Encryption is fun and interesting. Encryption in Python. I'm just trying to get enough letters so we can try to see some repetition in here. So keyword tortilla. So any T's? There's a T. There's a T. So 2 T's right there. And that corresponds to what? Let's see. A, B, C, D. Perfect. So in the word and, this is the word and right here, both the A and the D in the word and are equal to T's. And that's a little bit of a problem. You're going to run into the same thing with L. So A, B, C, D, E, F, G. F and G are both going to turn into L's as well. So the way that a keyword cipher works is if the letter is in the keyword more than once, you ignore it the second time. So that's what we need to do. So in my code up here, where I told it to add in the user key into valid letters, I needed to also make sure that it was not already in the key. So if char invalid letters, and if char not in key, then do this, then add it in, and now it should be okay. So if we run this again, secret message, tacos are... Wait. I want to make sure that we run into that same problem again. Wait. Oh, I know. The word and was a problem, right? So tacos... Hey, behave. Tacos and enchiladas are awesome. And my keyword again is tortilla. And now if we look, we can see there's only 1 T and there's only 1 L. And if we look at the word and, no more problem. So we have created a keyword cipher that is monoalphabetic, allows the user to input their own, and it works. Although, just to clean it up, we probably want to get rid of the printing the key. So, because otherwise that's a little weird. But yeah, we got it. Tacos and enchiladas are awesome. Keyword corgis. Beautiful. Now, this still isn't a great cipher, because even though there's a bunch of possible combinations and possible keys, there are patterns within the English language that do allow you to be able to look for different things that would allow you to crack this. And we'll talk about that in a future video. And we'll write some code to help us crack it.